Welcome to module 18 of Database Management Systems course in the IIT Madras online BSc program. In the last two modules, we have taken a look at the relational algebra, as well as in the last module we looked at the calculus. And we will interchangeably keep using these notions as we go forward to design the database, as well as we work on designing the query. From this module, we will start discussing the design process. How do you design a database system for a particular application, and what are the tools that are available? So, we will talk about ER model, entity relationship model, for real world representation. So, these are the contents. Now, talking about the design process, let us in general try to see that what is design, what do we mean by designing. Naturally, when you design for a requirement. You have a requirement specification or functional specification or something that you want to design for and meet those requirements. This could be a simple academic application like instructors, courses, students, course attendant, grades and all that. So, you will have to know the total functional specification for it. You need to know who are the stakeholders, what kind of constraints or what kind of rules, business rules will exist in that, or it could be a financial application, it could be a banking situation, it could be any of these, but the first thing of a design is to know the functional specification. That is the key area. And then you will have to do a design which conform to the limitations of the target medium, right, because depending on the requirement, if you have the requirement of an academic program and you say that I need a supercomputer to run this, obviously that will not be possible. But for a small database application for a small store, it may be fine to have a single user PC to run that program. So, you have to know what the specifications are and what the target system is, and accordingly you have to make the design. And you have to implicitly or explicitly meet all requirements of performance, resource usage. Some will have lot of concurrent use like the banking application, a response time of under a second. Some will have a single user application. Some will have a very distributed, say nationwide distributed application like your CoWIN application or Aarogya application and so on. All of them have big databases behind them. So, you have to satisfy implicitly or explicitly the design criteria that you set for yourself, and in the form of artifacts you must satisfy them and satisfy the restrictions that are possible. So, these are very global gross thoughts that you will have in your mind when you go about doing the design. Now, at the beginning of the design process, let me just remind you that design process has two key components to start with. One is the abstraction and the other is the model. Abstraction is you can look at the same information at multiple levels of granularity or representation, and we need the abstraction so that we can mentally handle it. Like human brain has a limited capacity, it is the short term memory as it is called. It has storage limitation. At a time we can remember about 5 to 7 items together, not more than that. There is a speed limitation of the human brain. So, we always need to abstract things down, so that we have the information, but it needs lot less memory, time and effort to understand that information, And of course, in terms of doing that, you ignore a lot of details which may not be relevant for it. So, this is again a mental process which has to stay with you, that always focus on what is the required information and abstract on them and work with them, while you will ignore all the remaining details. For example, in the student academic application, when you are dealing with courses, grades and so on, the say the salary of the instructor or say the date of birth of the student are unnecessary information, because you do not need them in this context. So, your abstraction is just around courses and academic connection. Whereas, when you are working with the departmental budget, you are really not that concerned about which courses the instructor is teaching, but you are very concerned about what is the salary of the instructor, what is the infrastructure cost to support that instructor and so on. So, that is kind of the angle of the abstraction and particular. So, just to give you an example of abstraction here, I just to show you a simple binary string, and if I ask you to remember this string by just looking at it, naturally most of us would not be able to do it. But if we group these bits in terms of triplet and encode it in octal form, it is 6251. So, you will just need to look at it once and you know, right. So, this and this both have the same information, but the abstraction is different. By 6251 you can remember it very easily, and you can reconstruct the detailed information also. In this case, you do not need to ignore anything. Similarly, if you group these as 4 bits, it is CA9 in hexadecimal form. So, these are like you can just look at it and will remember. So, that is the value of abstraction, and you will always have to keep that in mind, that what is the appropriate level at which we abstract. The second aspect is there is a significant importance of building models. We are always dealing with the real world, but we have to deal with the real world in terms of certain mathematics, in terms of certain computing algorithms, in terms of certain computer system architecture and so on. So, we need to make models of the real world which mimic the real world. So, that if I want something to happen in the real world, I do a corresponding thing in the model and it will happen in the real world. If I do something in the model, its similar thing should corresponding thing should happen in the real world. So, just to give you examples, this is not specific to database design. If you think about physics, you have studied Newton's laws of motion. That is a model of motion. You have studied that s is equal to ut plus half at square. That is, the s is the distance travel, u is the initial velocity, t is the time elapsed, and a is the acceleration. Then this is the distance travel. Now, the distance travel is a physical entity. How much the train has gone from in this time from this station. So, should it have reached the next station, but you can reason about it, talk about it, analyze it by using this formula. So, that is the model of time distance. So, if you look into various kind of things you have already done in your school and high school, you have quantum mechanics. I mean, in physics it's full of models. You have quantum mechanics to describe certain real world situation which we cannot see by common eye. Chemistry is full of models, valency based structure for elements and compounds. Geography is models of maps, projections, electrical circuits. Many of you would have electrical background maybe. Kirchhoff's laws, transistor models, schematic diagrams. So, again if you see that there are several models for the same thing, and several models look at the abstraction from several angles. So, when you are doing Kirchhoff's loop equation, you are interested in voltage and current, whereas when you are doing the schematic diagram, you are interested just to understand how the connectivities are, what is going to happen. When you are doing interconnect routing, you are trying to see how it would look on the PCB. The same electrical component, electrical circuit is being viewed in several different ways, and these are the different models, and building model is a most important thing. So, before we start with the design process, we need to learn an appropriate framework for modeling the real world that is of consequence to our design requirements. So, the overall design process of a database I can divide into three parts. One is requirement analysis. How do you plan and that is, you acquire the requirements, you put the specifications, define the system. Then there is database design in the middle, which has logical and physical model design, and finally you go into the implementation, data conversion and test and so on. So, we will right now focus on the logical model part of it, that is, database designing has a logical part which we talked about, is a conceptual part. The other is a physical part of bits and bytes and pages and links and so on. So, we will come to we will start with the design process with database designing with the logical model. We will assume that the requirements have been captured. We will talk about requirements capture sometime later. We will talk about the physical model sometime later, and focusing on the logical model, we will go with a specific framework to design capture the logical model, which is called the entity relationship model. We talked about this loosely earlier too. An entity is basically anything that you can distinguish as every separate object or thing, and this distinction is done in terms of a set of attributes which might be enough to distinguish the entity. So, we have seen how we can distinguish instructors. So, the collection of instructors is an entity set, and every instructor is an entity who can be distinguished through the properties or the attributes that it has. And then we have relationships between multiple entity sets. So, there are entity set of instructor, there are entity set of courses, and there is a relationship between them which says it teaches. So, entity relationship model, which often is actually represented in terms of a diagram, is typically a framework to capture this kind of information. And once that is done, then we will go into actually getting into relational tables, and then we will go into a database normalization process, which will come as separate modules in a different week. So, we are going to get into the entity relationship model. So, the idea is very simple, that I want to model the requirements of an enterprise, of which I have got the specification. And first what we are trying to do is just capture the conceptual requirements, not getting into what are the queries that we are going to support, what is the timing that should be required, whether it is concurrent or non-concurrent and so on and so forth. We are not looking into all those, we are just trying to capture the basic concept of the enterprise to the utmost detail as possible. And for that we need three things. We need attributes which describe different elements in the whole real world, in the enterprise real world. These described by these attributes are entities, and a set of similar entities having the same set of attributes will form entity sets, and then we have relationships which are also sets, which are between two or more entity sets. So, this just formally speaking, what is an attribute? Is a property associated with the entity set, and based on certain values of the attributes, every entity must be identifiable uniquely. Now, an attribute may be simple or a composite attribute. We will just explain a little bit more in terms of what is composite attribute. Simple attribute is a number, is a varchar, is a character, is a string, and so on and so forth. Then an attribute could be single valued or multi valued. That is, what it means is for a particular entity, an attribute of that entity, it is possible that it takes multiple values. For example, if we are modeling persons, then it is very likely that the person will have more than one mobile number. Nowadays people are keeping 2-3 mobile numbers, some they use for normal calls, some they use for WhatsApp and so on. So, in that case, we have to see how we can keep, because there is only one field, say, for the phone number. But if the person has multiple phone numbers, and if we want to maintain that, then how do we handle that? So, this is basically the requirement of a multi-valued attribute. And there are certain attributes which are called derived, which cannot be kept directly, like I want to keep the age of a person. You cannot keep the age of the person, because the day you keep it, the next day it has become bad, because the age has changed. So, what you keep is the date of birth, and from the date of birth, on the day you want to know the age, you can compute the age. So, you actually are interested in the age, but you are not keeping age, you are keeping date of birth. So, you are deriving age from the date of birth. So, these are called derived attributes. So, these are the different types of attributes you will have, and a domain is a set of permitted values for each attribute. Now, coming to the composite attribute is one which has more than one component. For example, name. Typically, in a person's name, there is a first name, there is a last name, and often there is a middle name. Now, each one of these would be a string, possibly, and these three together forms the attribute notion of name, because if a name differs in any one of these three, then it is a different name possibly, or we may have rules that no, in these conditions it is not. For example, you can say that the middle name is not of consequence in identification, just the first name and last name will matter, but the fact is that it is not one data entity, simple entity which describes the attribute, it has multiple. For example, in terms of address is typically composed of street, city, state, postal code and so on. Street in turn will be composite in terms of street number, street name, apartment number and so on. So, even date could be considered as a composite attribute, because it has a day, it has a month, it has a year, but if you are working in a system like SQL, which has date as a built in primitive type itself, then you will consider date for that system, for that modeling to be a simple attribute. But if you are just working on a system which has say numbers to represent, numerics to represent, then date also is a composite attribute. So, we will have to see that in case of a composite attribute, how do we actually model it and represent them. Now, entity sets are clearly sets of distinguishable objects qualified by the attributes, and you have already seen that. Instructor, course, all these we have been using for long. So, you represent the entity set by the list of attributes, particular order is not important, and you with an underline you show what is the primary key. You all know what is the meaning of primary key. Primary key is that one or set of attributes which can uniquely identify every entity in that set. So, you underline that or the set of attributes. So, this is typically the entity sets, this is instructor ID and name, student ID and name, you have seen quite a bit of this already. Relationships in contrast are what is defined between, say initially let us assume between two entity sets. So, we say we have students, we have instructors, and we are interested to define a relationship of advisor, which says that if the Peltier is related to Einstein, it means that Einstein is the advisor for or supervisor for Peltier. Right? So, this will mean that advisor is kind of a relationship set which has the primary key of the student entity and the primary key of instructor entity, denoting that these two are related. So, these are the relationships, and you can this is I am talking about two entity sets. This could in general be for any n entity sets E1, E2, En, and now you can see this is basically a domain relational calculus kind of representation. So, this n tuple is the relationship between these n different entity sets. So, these link arrows show the relationship between instructor and student as advisor. So, Crick is the advisor for Tanaka, Katz is the advisor for Shankar and Zhang, and so on and so forth. Now, it is possible that in relationship it is not just the linkage, but the relationship itself could have an attribute. For example, you want to in the advisor you want to maintain the information that well Crick is the advisor of Tanaka, and I want to know the date from which Creek has become the advisor of Tanaka. So, you can put that as an attribute on that relation also. So, that is a new concept coming. We talked about attributes only for entities, but attributes could be with an association with of the relationship. We will see this more. Then it depends on the degree, whether the relationship is binary or it is more than binary, ternary, quaternary or so on. Most relationships sets in the database are binary, and that is what is preferred, and we often if we have a situation of a ternary relationship or more, we try to break it down into binary relationship maybe. For example, if we are talking about a project guide relationship, it is just not a simple guide as we had earlier, but it is a project guide. So, then you need to know three things. You need to know the instructor, will be the guide. You need to know the student for whom the guide is, and you need to know the project in which the instructor is guiding the student. Right? In a different project, a different instructor may guide the student, right? And so on and so forth. So, this is a three-way relation, ternary relation, and we will have to be able to represent those. So, that is what is called the degree. We will see that in some cases, and this will come out more in the as we unfold the design process, that through the relationship many a times certain attributes may become redundant. For example, instructor here has a department name, and department of course has department name, which is the key and the details. Now, to set a relationship, if we say that there is a works for relationship between the instructor and the department, then it is through this relationship it is known what is the department of the instructor, right. So, it may be okay to drop this department name from the instructor table, right. Because that relationship we will talk of. This is ID, which is the instructor, this is department name, works for is a relationship which says what is the department of the instructor. So, we can see that this kind of attributes are often called a redundant attribute. Now, whether or not this is redundant depends on the other context of relationships and so on. For example, if department name was enough and there was no other details given, if there was no department entity set, then obviously this is not redundant, right. And we will see that if we drop it because of redundancy, oftentimes when we convert this ER model back into the relational tables, you might get this attribute back in the table for different reasons. Now, there are certain cardinality constraints based on how many entities in one entity set in the relationship is connected to how many entities in the other entity set that it is connected to, and there are different forms. Let us go one by one. So, the first type is one to one, which says that every entity in set A is connected to exactly one entity in set B. Now, this could be partial, this could be total, which means that it could be one to one total, which means that every element in A is related to one unique element in B. Uniqueness is the requirement of one to one, and every element in B is connected to a unique element in A. Now, it may be possible that some elements in A do not have a relationship with any element in B, or some element in B does not have a relationship with an element in A. Then we will say it is partial in terms of one to one, but the basic idea is no two entities can be related to more than one entity, right. You can have one to many, where from the first set to the second, one entity in the first set may be related to more than one entity in the second set, right. If that happens, then you say it is a one to many, right. Like if we say parent, if I say that a person and child, right. Now, a child has a unique father, but a father may have multiple children, right. So, it is one to many, from the father to the child, it is one to many. One father may have multiple children, but every child will have a unique father, it is like that. Similarly, it can be the other way, it can be many to one. So, it is just the ordering, if you change the ordering, one to many will become many to one, and there could be many to many relationships, right. There are course and student, and the relationship is takes. Every student takes multiple courses, every course is taken by multiple students, right. So, it is many to many. So, these are the cardinality mappings that you have. There is a concept of a weak entity set. We have learned that the entity set will be distinguishable and will have a primary key. More formally, these entity sets are called strong entity sets. Now, if I have an entity set where there is no primary key, but maybe there is a set of attributes typically called discriminator, which uniquely identify a group of entities in that set. So, these are typically called weak entity set, right. So, if I have a weak entity set, naturally I cannot work with that independently. So, weak entity sets feature in relationship with a strong entity set. So, see what is let me first go to the example, let us say. So, let us say I have an entity set building, which has building number, building name, address. Building number is unique. So, this is a primary key and it is a strong entity set. I have another entity set called apartment, which has the door number and the floor. Now, this door number is not a primary key of the apartment, because the same door number may be there in apartments in multiple buildings. Door number 201 may exist in multiple buildings. So, just by door number you cannot uniquely identify the apartment. Now, let us suppose that there is a relationship, say call it BA, between the building and apartment, which associates that, which says that every apartment, which building does it belong to, right. And naturally, every apartment can belong to only one building, but a building will have many apartments in it. So, from building to apartment, it is many to one, right. We can have that relationship. Now, we would also need that in BA, the apartment has a total participation, because it is not separately identifiable. An apartment cannot exist without the building being there, right. So, if an apartment exists, it must have a building, right. So, this is called total participation, which means that every entity in the apartment set must have a association through BA relationship to a building entity, whereas for a building it is a partial participation, because I can have a building which does not yet have apartments. Interiors have not been done, the walls have not been made, partitioning has not been done. So, there could be buildings without apartments, but there cannot be apartments without building. So, apartment to building is a total participation, and that is the requirement of a weak entity set, because unless you have total participation, since weak entity set, just the door number cannot identify every apartment uniquely, you need the association of the building to get that unique identity. So, what is that unique identity? Is the primary key of the strong entity set building and the discriminator, your own discriminator, the weak entity set's discriminator, which is door number here. These two together will form the primary key of the weak entity set. So, you can see that Actually, through the relationship it is borrowing the identity from some other entity set. So, if an entity set is strong, it has a primary key which is shown by underline. If an entity set is weak, it has a discriminator which is called the Doan number. And the relationship, I am just going back one slide because I jumped. So, on this relationship B A that you have seen is called the identifying relationship, because through this relationship every entity in the weak entity set is getting their identity. And the basic two rules are that the weak entity set must have a total participation in the relationship, and the primary key of the weak entity set is its own discriminator plus union with the primary key of the strong entity set it is related with. We will see that there are weak entity sets have lot of requirements. This is just another example from the course schema that we have been using. I will encourage you to study this and understand. So, this brings us to the end. So, we have discussed the initial part of the design process of database systems and getting into the logical modeling and elucidated the framework of ER model, and we will continue with this in the next module. Thank you very much for your attention and see you in the next module.